Hello friends, today's question. A rod of length L and mass m is hinged at point O. A small bullet of mass m hits the rod as shown in figure. The bullet gets embedded in the rod. Find the angular velocity of the system just after the impact. So we have a rod which is hinged at point O. Rod has a mass of capital M and length is L, and bullet traveling with velocity v and having mass m strikes the rod right at the bottom, and it is obviously going to move in this direction where the bullet gets embedded in the rod. And let us say that the angular velocity with which the system moves is given as omega. So in this case we are going to use the conservation of angular momentum. Initial angular momentum will be equal to final angular momentum. Okay. So let us first of all find out the initial angular momentum. Initial angular momentum. So just before the impact, the bullet is having a linear momentum and rod is stationary. So you can say just before impact, bullet has linear momentum and the rod is stationary. Therefore, we can say that initial angular momentum of the bullet about point O. Therefore, the initial angular momentum of the bullet about point O. Let us suppose we write this as L initial, and which will be given as mv and multiply by the length of the rod, which is given as capital L. Now we are going to write the equation for the final angular momentum. Final angular momentum. Now after the impact, the bullet gets embedded in the rod. So you can say that after the impact, bullet and the rod will move together, will rotate together. Together with angular velocity omega. So therefore we can say that L final, that is angular momentum final, will be equal to moment of inertia of rod plus bullet and multiply by the angular velocity omega. So we can find out moment of inertia of the rod. Moment of inertia of rod is equal to 1/3 ml square, and we can write moment of inertia of the bullet. Moment of inertia of bullet will be equal to ml square. Now we substitute these two values in the equation. Therefore we get L final will be equal to 1/3 ml square plus ml square multiplied by angular velocity omega. Now we can use the conservation of angular momentum. Conservation of angular momentum. L initial will be equal to L final. Angular momentum initial will be equal to angular momentum final. So simply substituting the value, we get mvl is equal to half m small m, taking L square as common, multiplied by omega. So this L goes with this square. So from here we can write that our omega will be equal to, this is 1/3, not 1/2. So we get this as 3 mv divided by L m plus 3m. So this is the final angular velocity of the system. This is the final angular velocity of the system, and herein the system means rod plus bullet. Just after the impact. Just after the impact. So this completes the question. Thank you.